Good evening, students. We are going to look into a few more of the MCQs. Probably these are level 2, whatever we are discussing now. Very important concepts you will see in this session. The question number 5, two circles of unequal radii centered at A and B. They touch each other externally at T. Let us make a kind of representative diagram. As you can see in the question, we do not have the equations of circles. We have no information regarding equation of circle. Only certain geometric details like the radius, some detail about tangent is given. Two circles having unequal radii, they touch each other externally at T. Done. They have their centers at A and B. So let me mark. Let me also join the line A to B through T. BD is tangent to the first circle at D. So that means from B, center of second circle, you are making tangent to first circle, and that is called tangent BD. Then TC is transverse common tangent, or in other words simply common tangent at the point of contact. So you can call it CT or TC, transverse common tangent. It meets BD at C. That's how the point C is formed. Also AT has length 3, BT has length 2. So these are the geometric detail given. Also AT has length, okay, they are asking for the length of CD. We require the length of line segment CD. Okay, let us recall some basic properties from lower classes. I am going to join the line AC also, and the angle AD radius makes with tangent, you know it is 90. The transverse common tangent also makes 90 with line AB. AC is a common line, so therefore you can understand also we know CD and CT are equal because they are pair of tangents. Because they are pair of tangents drawn from, you can say, from C to the first circle. So CD is, you can say, tangent from point C to the point D, and CT is another tangent. So their lengths are equal, CD equal to CT. So in effect, before finding CD, it is rather easier to find length CT. So that is a smarter approach. The choices are 2, 5 by 2, 3 by 2 and 1 by 2. That's given. I am just going to highlight the radius AD here. AD, it is radius of first circle, which is 3 units, and AB is 5 units together. AB, you can see it is AT plus TB together, it makes 5 units. And from the right angled triangle ADB, we get length BD. We get length BD by again Pythagoras theorem. It is 5 square minus 3 square, you get length 4. So BD has length 4. So I am going to make this triangle, assuming this angle is theta, that angle B. Okay, I have length BD. So you can see AD is 3, BD is 4. So I can get some details regarding all trigonometric ratios of the angle theta from the right angled triangle. From the right angle triangle, my intention is to get all the trigonometry ratio. You may require sin theta or cos or tan theta. Fine. So from the diagram, okay, I am going to again highlight that part what we require. There is 2 available here, and there is this end is T, that is C, okay. So we know this much, we have some information regarding theta, and we have the base BT is equal to 2. So this is helping you to find CT. We know CT by TB is opposite side by adjacent side only. This is a basic trigonometric understanding. It gives you tan theta. But we already have some idea about tan theta from the right angle triangle BAD. So from that triangle we already have tan theta, which is opposite side by adjacent side. And I am going to the left hand side now. CT in numerator, denominator TB measurement is 2. Therefore you get measurement of CT is 3 by 2, which is also the measurement of CD, which is there in the question. So the correct option is 3 by 2. Is it there in the option? Yes, you find it in the option C. So students are, I think you are getting a different kind of exposure without the without the formal equation, Cartesian equation of the circles given. You have only the dimensions of radii. So first radius is 3, second radius 2, they told you, and they mentioned what is the length BD, what is the tangent, how it is drawn, and how transverse common is drawn, where it meets. So you are asked to find CD, and properties we have used many properties conceptually. CD equal to CT is one property, and we used the property of right angle triangle from triangle ADB, and we made use of 2 right angle triangles involving the same angle theta, corner angle theta of B. So from corner B we are able to look at right angle triangle BTC also, right angle triangle BDA also. By connecting we got the answer CD, which is CT, measurements 3 by 2. Okay, fine. So I hope that's quite understandable for you. Let's discuss question number 6. The equations of the tangents to the circle x square plus y square equal 10, which means center at origin and radius is square root 10. And you want the equations of tangents drawn from the point. We want tangents drawn from the point 4, minus 2. Well, you can address it in so many different ways. You can solve. We want tangent from. So from means the point is not on the circle. If the point lies on the circle, students, you know very well, it is easy. You have a procedure called the T procedure. You can very easily replace x square with xx1, y squared with yy1, and so on. You have much knowledge from that. But here you require tangent from an external point to the circle, which means you can use the property y equal to mx plus c is a tangent to the basic circle if the constant c square equal radius square times m square plus 1. Okay, all right, and you can discover the 2 values. You will get quadratic in m. You get a quadratic equation in m. You will get double roots. So the 2 tangents will be highlighted. Actually, there is one option not visible for you. Let me make that option here, the D option, which is none only. Okay. So somewhere either A or B or C turns out to be the correct choice, or we are not very sure. Okay, right now you are not sure. Let me give you a fantastic clue. See, what is this point 4 comma minus 2? How this is related to this circle? Number one, this point is outside this circle. That's a very basic fact. There is one more interesting fact. In our previous session also, we made use of something called director circle. Director circle. You remember we used the same concept in solving the angle between the pair of tangents as 2 theta, etc. Okay. So there also we discussed. Here again, let me tell you, the radius here is root of 10. If you measure the distance from center to this point 4 comma minus 2, what is the distance? What is the distance? Let me name this point P. Okay, what is distance CP? Okay, it is root of 4 minus 0 the whole square minus 2 minus 0 the whole square. So you get root of 20, and root of 20, is it not root 2 times of root 10, root 20? Okay, can you study the relation between root 20 and root 10 now? I am highlighting. The given circle has radius root 10, and now you are getting a distance called root 20. That is the distance between the center of the first circle to the point 4 comma minus 2. So what do you think is the relation? So the point 4 comma minus 2, I am writing the conclusion now. I don't know how many of you are able to guess. This point 4 comma minus 2 lies on the director circle. It is part of director circle. I hope many of you are understanding, at least now after I highlight the truth, fact. 4 comma minus 2, the distance we verified from origin to 4 comma minus 2, you got the distance as capital R is root 2 times small r. So we got root 20 here, and this is root 2 times root 10. They both are equal. So that means director circle. What do you mean by director circle? Now what is the definition of director circle? It is the locus of the point which is point of intersection of mutually perpendicular tangents. It is the locus of mutually perpendicular tangents. This is very important. So mutually perpendicular tangents, and what you have in option A, B, C, they are tangents. So it's just a matter of verifying whether in option A, do you have mutually perpendicular tangents? Verify. The first line has slope -1. I am going to check the product m1 into minus m1 into m2. The first slope is -1. The second slope minus coefficient of x by coefficient of y minus 3 by 2. So this is not -1. So it does not form pair of mutually perpendicular tangents. What about option B? The x coefficient negative by y coefficient minus 5 times m2. The other line given by the side is negative coefficient of x by coefficient of y. This is also not -1. What about option C? Okay, first slope -3 and next slope 1 by 3. Yes, I get the product -1. So option C alone gives you pair of perpendicular, mutually perpendicular tangents, and that is the answer for the question, because it's a pair of perpendicular tangents. Pair of perpendicular tangents only, they form director circle, and only on director circle the given point lies 4 comma minus 2. Therefore it is an easy job by checking from the option. Okay, so otherwise solving using the regular routine CBSE procedure of using the concept condition for y equal to mx plus c to be tangent, c squared equal to r squared times m squared plus 1, finding the double root, okay, m1, m2, etc., and solving the pair of equation will take quite a long time, okay, for which you do not have sufficient time available in the exam hall in JEE mains. Okay, hardly you get about 2.5 minutes. So please understand, this is the concept. You can make note in the meantime. Okay, we will go switch to the next pair of questions. Thank you. Yes, we are here again going to the next question, the equations of tangent to the circle x squared plus y squared minus of 4x minus of 6y minus 12 equal to 0. The criterion given is the tangent must be perpendicular to the line 2x minus of y equal to 7. Well, now actually I know you students, you have a lot of ways of doing it because you have completed the entire class 11, class 12 course. You people can also look at it as an applications of derivative question wherein you can differentiate, get the slope of tangent, etc. Okay, so that's one way of looking at it. But going by the coordinate geometry method will always be a bit easier. See, what we want is tangent perpendicular to this line 2x minus y plus 7. Well, you can easily judge from the given options which pair may be the required tangent, because the moment you say the tangent is perpendicular, okay, you remember Raghunathan's method of preparing perpendicularity shortcut. The 2 comes here, coefficient 1 goes there, and the sign changes, put x, put y. So you know our method. So the x term and y term, it must be x plus 2y only. So you find the kind of x plus 2y terms in option A also, in option B also. Well, so in that case, now who will decide the correct option? X plus 2y is equal to, or plus some constant is equal to 0. So we are not able to decide the constant right away. But You know this is the general equation of circle, it is not a basic circle. So you have the center point very well known, it is 2 comma 3. Fine. The radius well known. Yeah, you can calculate g square plus f square, 2 squared plus 3 squared 9. Change the sign of the constant. So you get the radius, answer 5, the square root 25. So the radius being 5. So all you need to do is take option A and see which one gives the radius 5. How will you check the radius 5? We are going to do the line, if at all it touches the perpendicular distance. Perpendicular distance must be equal to radius. So we are going to use this concept. So perpendicular distance. So let us take the first option. Let me assume x plus 2y minus of 8 plus 5 root 5 equal to 0. Okay. Or in other words, you can actually take the unknown constant k directly. Also you can work it out, d. So that means 2 times of 3 plus k divided by root over of 2 squared plus 1 squared. It must be equal to r is 5. Cross multiplying, we get mod of 8 plus k is 5 root 5, or 8 plus k equal plus or minus of 5 root 5. So you are able to discover the constant very simply, minus k plus or minus 5 root 5. So which already implies option A should be the correct answer. So option A has minus 8 plus 5 root 5 in one of the lines, tangent line, minus 8 minus 5 root 5 in another tangent line. So we understand this is the option A is the correct answer without difficulty. So what we did, please recollect, we want to find tangent perpendicular to the line 2x minus y equal to 7. Okay, applications of derivative, it may be helpful, but it may not give an answer as quick as this. So always go by coordinate geometry procedure. So d equal to r is a well-known procedure for general circle, general line. If you have basic circle, basic line, then it is, you know the answer, c squared is equal to r squared times m squared plus 1. I am reminding you, though it is not part of this question. Fine. So shall we move on? Let us discuss question number 8. There is a point P root 3 comma 1. There is a point. It moves on the circle x square plus y squared equal 4. So you understand immediately the center point, the radius, okay, the basic properties of the circle which is necessary. And after covering it moves, see the point moves on the circle, covers 1/4 of the circle and then leaves it tangentially is the. So let us try to picturize. So origin, the radius is 2. This point is 2 comma 0. This point is 0 comma 2. And we are discussing what will happen to the point root 3 comma 1. Okay, root 3 comma 1. This root 3 comma 1, we are not clear. Or the question doesn't state clearly. It moves. It simply says it moves. Okay, and through a distance 1/4 of the circle. So we are not clear, is it happening anti-clockwise or is it happening clockwise? So that's a challenge now. So also if you look at the option, each option has a pair of lines. So it's not one line only, it's a pair of lines. So that means I assume, as a student, I assume maybe one for anti-clockwise direction and one for clockwise direction. That's the way anyone thinks. Well, how will you decide after 1/4 of the circular rotation the point moves, where it will end up? How to decide if it is anti-clockwise or if it is clockwise? I am marking 2 points. Let us say this is a Q. Let me mark Q dash. So if the point had to move anti-clockwise direction, it would reach Q after 1/4 of the circle. What do you mean by 1/4 of the circle? The circle has 2 pi radian. So 1/4 is 1/4 of 2 pi. Okay, 1/4 of the circle, which simply means angle 2 pi by 4 or simply pi by 2. Angular rotation is pi by 2, anticlockwise or clockwise. So I would like to remind you a very important feature of the circle. We know if x square plus y squared equal to r square, then the parametric form is x equal to r cos theta and y equal r sin theta. X equal to r cos theta, y equal to r sin theta. In this case r is 2, so it is 2 cos theta, 2 sin theta. So that's how you will represent any coordinate. In that case, what will be the angle theta for P? So at P, what is the angle theta? 2 cos theta is √3 and 2 sin theta, that is the y coordinate, is 1. So what I am supposed to assume then? Cos theta is √3 by 2, sin theta is 1 by 2. Okay, so that means the theta, you know, it is a well-known angle, a standard angle, pi by 6. So this angle with respect to positive x-axis, it is pi by 6. That's a very important clue, understanding you get by assuming the what we call the parametric equation of the circle in the form of r cos theta and r sin theta. Good. So what we shall do now? We will take, if I assume anti-clockwise direction, assuming anti-clockwise direction, you arrive at new angle. Let us say if the position theta dash here, theta dash will be the original angle. After moving pi by 2, it has to be 30 degree plus 90 degree. You get 2 pi by 3. Very simple. So once you get the angle 2 pi by 3, you know x equal to r cos theta dash. So 2 cos 2 pi by 3. Y similarly, it is r sin theta dash. So I am replacing theta dash with 2 pi by 3. Y is 2 sin 2 pi by 3. And 2 pi by 3 is minus half. So I get minus 1 here and positive √3 over there. So the coordinates of Q has coordinates minus 1 comma √3. That's a very important conclusion. Very important conclusion. Once you get to know the point on the circle, then it's very easy to judge what is the tangent equation. What is the tangent equation? Why are we finding tangent equation in the first place? What is asked? The equation of the line along which the point moves tangentially. So assume this point is rotating along the circle and suddenly leaves tangentially. So definitely it is a straight line and it is a tangent line at Q. So all we require is the equation of tangent at Q. Finding equation of tangent at Q for you is very easy because you know the preparation of T in very easy terms. What is that? Replace x square with x1. Replace y square with y1. Nothing else is there. There is no x term or y term. So it's quite an easy go. Okay. Shall we start? So it's very easy. X square plus y square equal 4. So minus 1 comma root 3 at minus 1 comma root 3. So it is x into x1 plus y1 equal 4. Just look at the option where you find such a line, minus of x plus root 3y, or you can say root 3y is x plus 4. One of the options should be root 3y equal x plus 4, which is only found in option D. In D, the second line, it says root 3y is x plus 4. But there is another line also in the same option which says root 3y is x minus 4. Then is it also correct? Yeah, it is also correct, because that leaves from clockwise rotation leaving tangentially. Clockwise rotation leaving tangentially. So what is the point q dash then? It's easy to get q dash. So q dash can be, okay, it should be what? If it is 2 pi by 3, then this should be subtract 180 from 120, or you can from this is minus of pi by 3. How do you get it? Pi by 2 minus of, sorry, it is pi by 6 minus of pi by 2. Here we added pi by 6 and pi by 2. Here we do pi by 6 minus pi by 2, which is negative pi by 3. So negative pi by 3, so the point q dash will be simply 2 times of cos pi by negative pi by 3, okay, and again 2 times of sine of negative pi by 3. So it's going to be 1 comma negative root 3. So negative root 3, 1 comma negative root 3. Yes, 1 comma negative root 3, you find it satisfies the first line, root 3y equal to x minus 4 by substituting x equal to 1, y equal to negative root 3. Is that okay? So we have dealt with a couple of questions which are belonging, not exactly the easy variety. I always kept on telling you students, there will be level wise, you grade the question paper when you attend. Okay, we are targeting JEE main, and it is what you call your you have to prioritize the easily doables or the average variety. So the topics what we have dealt today, this is not the average variety also. Okay, so you need to go through elaborate conceptual brainstorming and then come to the concept. We used here the powerful concept parametric format for x equal to r cos theta and y equal to r sin theta. You are able to then complete the T procedure, you are able to get the equation of tangent. Okay, so stopping here, I give you time to just go through the solution, and then later on we'll move on to the next part of questions. Thank you.